to day two of this amazing hackathon. Right now, we're about to start the workshop on Llama Stack with their team from Meta. So, welcome also the people joining us online. Yes, thank you very much. Enjoy.
Hello, everyone. I'm Raghutam Murthy. I'm an engineer in the GenAI team at Meta, working on Llama Stack. And in this workshop, it will be kind of two parts. One will be about just like an overall intro of like why we did Llama Stack, and a little bit around kind of the motivation. And then we'll have Randy kind of talk about the actual developer experience with Llama Stack to build agentic applications on top of Llama models. So until about July, Meta was mainly just releasing model weights uh, in open source. So these were text weights. They were of different sizes. They had different sets of capabilities. But the exercise to actually use these models to build applications was left to the community to kind of figure out. And while we were releasing these weights, we were talking to uh, like developers as well as kind of providers to be able to see how we can actually improve things. So when we talk to developers, we heard that developers wanted to get started very quickly. They just were getting weights, and actually using it was like pretty hard. They had to go through a bunch of steps. But at the same time, they wanted to have the flexibility of open models. So with closed models, you'll be able to just hit an endpoint and get what you need. But with open models, you have a bunch of flexibility of wanting to kind of fine tune the models, being able to kind of use your own data with it without actually having to lose control over your data. They wanted to have all of that, but at the same time, they wanted the ease of use. And we also have providers that we work with. So these are folks who take our models and provide services on top of that. So if you look at Together, who is a sponsor here, or Fireworks, or any of the cloud providers, they would take our models that we open source, and they would offer it to their own developers. And what they found was actually serving the Llama models was actually a fairly kind of involved exercise for them as well. They had to first of all kind of figure out what the best way to kind of serve these models was, and we would work with them as their partners. And also, because there are no kind of standards to which they could actually build to, they had to build a bunch of integrations to a bunch of other providers that were also there in the ecosystem. So there's a lot of complexity for any company that is trying to provide services on top of Llama models as well. And ultimately, what I think both developers and providers wanted was a set of codified best practices, so that when Meta actually ships these models in open source, they're able to immediately start providing the value of those models to the developers. And while we are listening from the community of developers and providers, we are also building apps internally within Meta. So you've probably seen Meta AI. There's also AI Studio. These are very high scale kind of applications. Meta AI, for example, recently crossed 500 million users, and they all use Llama models. So we know pretty well what it takes to actually build production grade applications on top of Llama models. And we took those experiences to then start figuring out how can we package that experience into something that we can actually share with the ecosystem. And that is what we ended up calling Llama Stack. The Llama Stack is basically a set of standard. It started off as like just a set of standard interfaces to build canonical application or canonical kind of tool chains, as well as the best way to actually build agentic applications on top of Llama models. It's a spec as well as a bunch of implementations. I'll go into what exactly each of those actually means. If you think about what the spec itself is, it consists of two parts. One is the model toolchain, or the LLM ops part, which includes, of course, like your regular inference, batch inference. In addition to that, there's also APIs for fine tuning, running evals, even doing like pretty sophisticated things like synthetic data generation. For agentic system, there's a bunch of primitives that are needed in order to build agentic applications. This includes memory, which I guess is a generic form for RAG, and there are other things like shields for safety and tool calling, which are pretty essential to build agentic applications. So this is the spec. So we released this spec as an RFC back in July, and we got quite a bit of feedback from the community as well as both developers and providers. And for the past few months, we've been working with a lot of these providers to build implementations of these APIs. And we call these implementations providers. And just having providers for inference and real time or batch, as well as fine tuning and so on, you'll just get like a whole slew of providers. We also wanted to make it a lot easier to package all of these providers as well. And that's why we came up with this concept of a distribution, where the idea is you take providers for different capabilities. It could be inference, fine tuning, and so on. And you package those providers into a single package so that from a developer perspective, they're able to just spin up something that is very easy, or even the providers can provide a single endpoint that can provide all of these APIs. So both from a provider point of view as well as from a developer point of view, having this notion of a distribution made it so that you don't have to worry about dealing with a ton of choice that typically kind of makes it much harder. And there's a ton of partners, and we are launching with more if you go to our kind of GitHub. So if you think about what we are trying to achieve with Llama Stack, for developers, we have kind of pretty easy to adopt APIs in multiple languages. So we have Python, of course, and Node and Kotlin are being actively worked on, as well as Swift SDK. So if you're building mobile apps using kind of Llama models, you can actually use our the Llama Stack SDKs as well. And as a developer, depending on what type of environment you want to work on, it could be on-prem, if you're like a large enterprise. It could be on a single node or like on your own laptop, for example. Or it could be hosted or as a SaaS service, like for example, Together and Fireworks. These are the two SaaS providers that we have already. And you're also able to build applications on mobile. So this is on device. So as a developer, you have the choice of picking whichever environment you want to work on, but then the APIs remain the same. And the best part is once you build an application, you just change the endpoint and the application works without any code changes in different environments, right? That's one of the things that, especially around on-device development, we have found a lot of convenience there. And again, for developers, we have codified best practices so that you don't have to worry about what like mundane things like what are the recommended system prompts and so on. You get that as part of Llama Stack. And for providers, and these are all the folks that are providing services, there's now a standard API to build towards. They don't have to work on building a bunch of integrations. And they're able to actually focus on a lot more around differentiation. So if you, again, think about Together or Fireworks, they're focused a lot on very, very high performance inference. They don't have to worry about how people are building agentic apps with like different, let's say, vector databases, because they're all available as providers for memory in Llama Stack. And finally, Meta is actually investing a bunch of time in building out automation so that we can actually verify these distributions. So as a developer, if you just work with a Meta verified distribution, you know that your experience is going to be something that Meta is actually kind of advertising for kind of how you use Llama models, as well as the best way to even build agentic applications using Llama. So this is like a very, very quick overview. I can just maybe open it up for questions if that's okay. Otherwise, we'll have Randy come over and talk more about the actual developer experience itself by taking you through a notebook. Thank you.
Cool. Good morning. Good morning. Hope you guys get some coffee and are awake and ready to hack. I think the goal of the next 15 to 20 minutes is try to convince you to use Llama Stack and why you should use Llama Stack. I think Raghu give you some good understanding of what Llama Stack is and how and why you should use it. I'm gonna share with you a bunch of developer journey experiences on how you can actually use it. So it's hot off the oven. We just merged a branch yesterday. on a series of getting started on the most popular use cases that you can use with Llama Stack. And the hope is by going through those things together, or even later on by yourself, we'll be here to help you around. You should be some expert in Llama Stack, and you can consider building applications using Llama Stack. Okay, let me slideshow this. So these are the key URLs that you would want to follow along. There's a bunch of notebooks that you can follow along throughout these discussions. You can play with it, give us some feedback, and we'll be happy to help you around with it. So these are the various different options that are supported from Llama Stack. So some of the most popular cloud providers that you have been using is also supporting Llama Stack. And the goal of Llama Stack is you build once, and you can switch between different providers, different combinations without having to rewrite your application. So that's like kind of the beauty on Llama Stack itself. So you build once, we expose a set of standardized APIs and interfaces, and then you can connect it with different providers depending on your use cases and your cost and your performance. So if you scan the first link or you click the URL, you will see a bunch of notebooks on how to get started. So we're going to go through that, and hopefully by the end of that, you will have some understanding of what is Llama Stack. So first, of course, the most popular use cases is inference. And Llama Stack has two components, actually. You need to set up like the server side itself. Once that is done, it will be exposing a bunch of API endpoints, right? Like a REST API endpoints. And you need to pick your client. We have 4 different clients: the Python-based client, the Node.js, the iOS, the Android. Depending on the type of applications you want to build, you pick one. In this example, I'm going to showcase the Python-based client. So with that itself, once you have your server set up by following the Getting Started guide, then you can instantiate the client itself, which is pretty simple, right? And then, as you guys are aware, this is how you construct your prompt. Nothing new. They are all based on the general industry trends on how you construct prompts. You have system prompts, you have user prompts, and then while you run it, you'll get a response. And as you guys are aware, like in order to build and get good results, you need to do a bit of prompt engineering. And I won't cover the whole prompt engineering as a topic, but depending on different models, different configurations, and different outcomes that you want to do, there might be different ways to do prompt engineering to make sure that you get good results. This is a simple way to do conversation loop. As you know, sometimes when you want to build a chat-based applications, you want a conversation to go continuously. Simple, just put it in a loop and add some keywords to stop. There's no magic here, right? Another important part is also on conversation history. As you guys are aware, in a chat-based applications, user tends to ask follow-up questions, and you might want to have the previous context or information. So in order to do that, you just create like an array of previous history of conversations, and you pipe that into the prompt itself, append with the latest ones, and that is how you construct the conversation history. So everything else doesn't change. So these are all the small little components that you can add depending on the type of use cases that you want to build. As you guys are aware, we also support streaming, which is a common trend. So if you want streaming, no big deal, just add stream, and you'll get the answer. Okay, this is some update, so it's kind of like a feature, but we're gonna make it tomorrow. Okay, it's gone. Cool. Next is, I think, as Raghu mentioned, Llama Stack does support local and cloud inferencing. So if you have like your local model hosted, you can also do local inferencing. And how you do that is, of course, you set up different pods for different models, and you have a logic of figuring out where and when to call which client. Think of it as a use cases. Hey, if you want to use the latest and the biggest Llama model, which is the 405B, most probably you can't host it locally, right? So you have to host it on the cloud. So and that part itself, you instantiate. Okay, seems like on a Saturday they want a lot of updates. Cool, we are back. So for the bigger models, you definitely want to host it on the cloud, use one of the cloud providers and whatsoever, so that it's like your remote inferences. But let's say you have also some use cases using smaller models, like the 8 billion models, the 3 billion models. So that could be hosted locally. For example, you can use Llama or even other options to do that. And in that case, you just need to instantiate 2 clients, right? One is the local client, the other one is the cloud client. And you can have some logic on different use cases to use which model. So Llama Stack does support that options, and that gives you the flexibility of mixing and matching your different use cases and using which model. Oh, okay, this is better. We have the URL. If it's too small, you add it back, scan it, the notebook is there, you can play around with it too. And the URL is this, okay? Let me flash it like for 5 seconds in case you want to scan it. Cool. Okay, that's for local and cloud. And then prompt engineering, Llama Stack does support like few short use cases too. So how you do it is pretty simple. You define a few examples, and then you pipe that in as a prompt, so then they know what is the expected response, and the result itself can be much better. Another interesting and in our latest release of Llama 3.2 is the capability of the vision model. And Llama Stack does support the vision API too for your vision use cases. And what it means is instead of just taking in text and generating text, now we can understand images and generate text out of it, right? I mean, the output is still text for now, but by opening out images as an input, that gives you a bunch of different use cases to unlock. For example, if you want to build something that try to understand some images, to do some OCR or something like that. So that's kind of available now with our latest vision model. And if you want to do that in Llama Stack, it's pretty simple. One key thing to take note is you need to convert your image to a base 64. That's how it's going to be understood in the model itself. Once you do that, you just need to actually pipe in the image as part of the content and ask the image to actually to be described by the model itself. So in this example, as you can see, I'm passing in like a Llama Stack logo image and ask him to actually describe the image. And it will give you the answer and the responses of what they think as an image. So think of it while you're building your use cases throughout the hackathon. If you want to build some cool vision use cases, then you can kind of use like the vision model as part of your experience to actually build that flow. And as previously mentioned, you don't just have to use one model, right? You can use the vision model as the first step, and then you can chain it with like a bigger model for like a more complex use cases. Those are also perfectly fine depending on your use cases, and you can mix and match between like a local inferencing and also the remote inferencing flow. Another powerful thing on Llama Stack or even LLM applications as in general is, of course, the concept of tool calling. And in one of our latest models that Meta released, we do support tool calling by default. There are some that we support, which is like Brave Search, Wolfram Alpha, and things like that. But that is not all. I'm going to showcase to you a quick example on how you can use the existing tool calling capabilities, but also build a custom one to extend your use cases. Because we know that, hey, your applications might have a very specific use cases to call different tools, right? I mean, tool is nothing but, think of it, there's nothing magic. So basically, tool calling means the ability for the LLM or the model to give you a formatted response with proper parameters that you have predefined, and therefore you have all the required information and parameters to call the tool yourself. And the tool can be anything. It can be an API request to whatever services or whatever tools that you have. So in that case, by exposing and making this tool calling capability available in the models, this kind of opens up a bunch of different cool use cases that you can think about, right? For example, if you are building like a mobile application, and if it's an Android phone, Android exposes a lot of intent-based capabilities, right? If you construct your tool calling to be able to kind of parse out the required parameters by the intent, then you can technically call different apps and do different cool things together and make the whole experience better. Yes? Yes. Yes. So JSON is one option of the structured output. So in the prompting itself, throughout the example, you will see how we can construct that and kind of direct the model to give you a structured output. Like, hey, you want a JSON response, you want it in a format of like a tool calling capability. That's also an option that you can do, and you can extend it into whatever use cases that you want. So in this example, we are using the Brave search agent, which is the ability to search the web for additional information. And think of it this way, because LLM is trained with limited set of information, right? It has cutoff date and things like that. And if you ask like a more current things, then they might not be able to give you responses. So by combining with like a popular web search capability, you can actually extend the capability of your model itself to a more current knowledge as an additional things to actually improve the response. Cool. This part is for custom tool creation. This is how you should follow the guide if you want to build your own custom tools. It's pretty simple. Define the class, create an agent, and then this is where the real magic happens, which is basically the API call, right? As I told you, the model will just give you structured response with the parameters that you define or you expect, and then it will pass into this API call function. That is when you actually make the real tool calling, like to whatever endpoint you want. In this case, it is a weather tool calling, which means that if you ask for like the weather in a certain locations, it can kind of get you the weather after it makes the call. So that's basically that. Yeah. So this template itself, you can reuse and you can just change it to whatever parameters. It's pretty simple. Like for example, in this weather example, I expect 2 parameters, right? Which is the city or the location and the date or the time. So if your tool example have more parameters, different type of data types, just change it. The model will give you different structured response, and then you make your API call through that. We have a few templates, like the tool calling templates, we have a few, like the search is one, the Wolfram Alpha is one. Maybe in the future we'll add more, but the ability to do custom ones kind of opens up more possibilities for you. So it's not restricted to just the one that we officially support. So this is an example. So you will get the parameters, and then we'll do the custom tool calling, and you will get the response. The next one is memory. I mean, this is an interesting topic, but you can also leverage Llama Stack and combine with this to give a better response in terms of like the context and stuff. So in order to have memory, you need to create and initialize the client like memory bank. You can use whatever configuration you want. In this example, as you can see, we are using this. But if you have any favorite one or you have experience in other configuration, you can use it. But it's nothing but a way to store information and then have the ability to search that information back that you can use to complement your overall prompt to the model itself. So think of it as a way to enhance the content of the prompt that you send to your model. So we also provide a way for you to insert the documents. So basically, it will be parsed first, as I explained before, and then after that, you will actually combine the documents and then store it in the memory bank. So this is like the command to actually insert the document that you have been parsing or the information that you have been parsing into the memory bank itself. And after you have populated your memory bank, then of course, you need to query the memory bank, right? So you query this memory bank before you call the model or before you construct the full prompt itself, so then you have additional information that it can actually pass into the prompt together. In this example, every single query to the memory bank will give you like some kind of scoring. So the scoring is sort of like the measure of the relevancy of the content itself with what you are trying to actually pull. So in this example, as you can see, when I ask how do I use LoRa, it gives me a bunch of results, and each of the results has a score. And technically, there are many different techniques on how you can use this information, but the best one or the most commonly used one will be like, hey, you stack rank them, and you pick like the top few and then use that as part of your prompt to actually get better response. Yes. Right. So Llama Stack itself doesn't control the pricing or the storage configurations, but we make it extendable such that you can use fireworks for certain parts of the application itself. I think Raghu mentioned like the whole chart of the various different capabilities, right? Like for example, in inferencing, I want to use solution A. In like memory or storage, I want you to use solution B. You can kind of mix and match that configurations, and that defines your whole Llama stack. So think of it as like we expose a bunch of building blocks, and each of the building blocks have different options for you to use. Like you want to use A, you want to use B, you want to use C, it's up to you. And each of them have different pricing, and you can kind of merge and come back with that for that.
Sorry, I also wanted to add that Fireworks, for example, they have exposed an API that is accessible for free for this event. So you can try it out in this event.
Cool. Next topic is on safety. While we are building interesting use cases, safety is also quite important. And it's nothing but leveraging additional models or ways to actually safeguard your prompts and also the output of the response. And in this case, we do have two options, prompt guard and llama guard. So prompt guard will actually filter out and check whether the prompt that the user is sending is safe or not. It will give you a score. It will give you a classifications, and then you can do whatever you want with the outcome of the classifications. And then on Llama Guard itself, you also have the ability to kind of process the response and give you some scoring on whether it is good or it is bad. And in order to configure safety, it's pretty simple. In the same config file that you have been using for all your Llama Stack configuration, just say, I want to use safety options with Llama Guard 1B. Then you have that available that you can use. So this is an example. So for example, I have two messages, and then you will be able to check that, okay, the first one is good, there's no violation, and the second one is not good, and it is categorized as like a safety violation with like this category. So Llama Guard itself does have different categorization of the violations, so that could help you kind of tailor your responses to your users and guide them to kind of ask like a different questions or things like that. Last one, agents. Like agents is nothing but a collection of different things that you can kind of combine together. In this case, there are a few components to kind of make sure that, hey, it is like a legit agent that can do something. For example, you need to make sure that the agent can actually run inferencing on either local or remote models. It can do some safety checks. It can also execute some tools. We have shown some examples on how we can do like a Brave search, the weather tool calling. So if you combine all these components together, then you can kind of call them as like an agentic application for like a certain use cases. So for the purpose of the hackathon, you can kind of play around with it, like think of further use cases that you want, and then see how you can kind of leverage Llama Stack as part of that. So, okay, it's kind of long. I'm not gonna go through every single one of those, but the TLDR here is these are our 7 0 to 1 hero guides. It is all step by step, notebook friendly. You can just click and run and see the expected response. So if you go through all this, you should have some good understanding on what Llama Stack is, how you can use Llama Stack for some of the most popular use cases that we have seen today. And if any of those doesn't meet your use cases or you have more questions, definitely let us know. We'll be around and happy to answer some more questions. Yep.
Hey, sorry, just I guess late breaking. We're actually announcing like a special prize for the best agentic app built on top of Llama Stack for $1,000. So just wanted to mention that.
Cool. That's That's good to know. That's another motivation why you should try Llama Stack. While you're thinking about it, hey, you might win the top prize, $10,000 or something, but hey, like nobody won less prizes. You can get another additional $1,000 if you are building applications using Llama Stack. Another last shout out is on Llama recipes. We have been talking a lot about Llama Stacks, but hey, Llama Stack is a tool chain that helps you build Llama-based applications. But let's say I have a more custom ones and maybe Llama Stack doesn't suit yet, or like I want to do fine tuning or things like that. We have a bunch of Llama recipes. Basically, it's an official companion to the Llama models. We have use cases, recipes to do fine tuning, synthetic data generation, and whatever you can think of is mostly there. And if it's not there, open an issue, put out a request, and we'll be happy to kind of work with you to get some of the examples out. So the whole goal is like, hey, we have Llama models, we have Llama recipe, and we have Llama Stack. So we have an end-to-end set of tools and use cases for you to think about on what you want to build in this hackathon. And of course, we'll be here throughout the day and also tomorrow to kind of help you with kind of either validating your use cases or kind of answer some of the technical parts or questions that you have in terms of like putting all the dots together on how to build a cool Llama-based application. So thank you. Any questions? Yes. Support on what? A fine tuning. Not yet. That's why Llama recipe is there. You can use Llama recipe to fine tune, but it'll be coming up. So if you're like your domain is on fine tuning, definitely keep a lookout on Llama Stack as we build out those capabilities. We love your feedback and how we can iterate together on that. Coming soon. Yeah. So just a bit of context, Llama Stack is pretty new. We released it a couple of months ago. There are some tractions, and if you can see the chart that we put together before, okay, not here, but we have been partnering with a lot of different partners too on making Llama Stack available on their platforms itself. So you would expect that in the coming months or so, the tool set offerings and the capabilities will mature more, and it's going to be more and more adopted and supported across different providers that you are using. And therefore, you as end developers, when you are building those applications, it's going to be a lot easier and simpler. Cool. Any last question? Yes. I mean, the model itself does support multi-languages, but then again, if you're talking about languages that are not supported yet, what we have seen the community use is they actually use the base model and they fine-tune that with like specific language data set. Like for example, I think we support up to like 10 different languages for now, but more in the future. But of course, if your use cases needs different languages, then one good recommendation step is to kind of get a base model size that works for you and then fine-tune that with a more language-specific data set. If the language is not supported, I think prompt engineering won't help. So I guess if you don't have that language support in the model, that won't help in terms of prompt engineering. Cool. Thank you so much. We'll be around and happy to help.
Thank you. Just quick announcements. Right now, we're about to start a new workshop. It's going to be hosted upstairs, so I would like to invite everybody to head upstairs. It's Restack, so it's a framework for autonomous intelligence. It's going to be presented by Philippe, the CTO of Restack. So we have a few more workshops. Also, remember you need to register to LabLab AI to participate. If there's any questions, you can always find me. And as well, if you would like to get access to Featherless API, you can find me, and I will happily distribute the API keys. Thank you.